Good morning and good afternoon, everyone. Thank you for joining us today. My name is Marie-Claude Allard. I'm the communication lead for CANU, the Canadian Urban Environmental Research Consortium. This is the fifth webinar from our equity-based climate adaptation project, which is being done in collaboration with CHASE, the Canadian Health Association for Sustainability and Equity, with funding from the FCM, the Federation of Canadian Municipalities. I would like to start by acknowledging that the Université de Montréal, where I work, is located on non-treaty Aboriginal territory. This land has long served as a site of meeting and exchange among Indigenous peoples. I wish to pay tribute to those who, since the time immemorial, have been its traditional custodians. Before we get started, I would like to remind you to turn off your camera and stay on mute during the webinar. If you have questions during the presentations, please put them in the chat. Our speakers will answer questions online when they can, and we will address any unanswered questions at the end of the session. Also, this presentation will be recorded and sent to all registered participants after the webinar. And now I will pass you on to Kim Perrotta, the Executive Director of CHASE, who will moderate this session.
This is the second of our case study webinars. We are excited about this session because it features innovative work being done in Toronto to manage stormwater in a manner that reduces the risk of flooding, decreases air temperatures in the city, and brings nature into the city streets. And this work is being done with an equity lens. We will hear from two people who work for the City of Toronto. Unfortunately, Christina could not join us today. She is already on another webinar. But we will be hearing from Anisha Patel, the project manager for asset management with transportation services, and from Nilafar Mahajarani, who's a senior engineer with stormwater management infrastructure, design and construction, linear underground infrastructure, engineering and construction services. And that is one mouthful for a title. So I'm going to turn things over to you, Anisha, and thank you.
All right, so thank you everyone for attending. Just a bit of an agenda here. So I'm going to do a bit of a general program overview, and then my colleague Nilu, she's going to get into some more specifics of some of the projects that she's been working on. But to start off, I want to provide some context for why our Green Streets program exists. And that's because we want to cushion the effects of urbanization as much as possible. So we want to find solutions that are going to help us move towards a more natural pre-development hydrologic cycle. And urbanization and development significantly impact how the hydrologic cycle functions compared to like a pre-development scenario. So the more you develop land and introduce hard surfaces, you amend that cycle. So you increase runoff, which can often contain pollutants and put strains on our sewer system as it relates to capacity. And you also reduce the amount of infiltration of water back into the ground. So you can't replenish those groundwater sources. And then you get less evapotranspiration as well. And in a city like Toronto, where we have a lot of hard surface, the impacts are really evident. So in addition to the impact on our hydrologic cycle, through urbanization, we also get a loss of vegetation, trees, and overall permeable surfaces. And trees, vegetation, and other soft surfaces like permeable surface solutions can help address the heat island effect. And that's much needed as we're projected to see increases in both the number of hot days we experience and overall temperatures in the future. So green streets, or green infrastructure as we call it, is one of the city's solutions to address some of the impacts of urbanization that we're experiencing. And so these assets are designed to capture stormwater, but also provide other co-benefits that aim to address the impacts of urbanization that we just reviewed. And so our assets are categorized into three primary buckets. So the first one is permeable hard surfaces. So these are things like permeable pavers, porous asphalt, or concrete. So they're designed to allow stormwater to infiltrate through the structures themselves or slow down peak flows. So you potentially return that stormwater back into the ground. So you're mimicking that natural hydrologic cycle. We also have our second category, which is bioretention, bioswales, and rain gardens. So these can be thought of as planting areas that accept drainage from adjacent roadways, cycle tracks, or sidewalks. And they often include an engineered media that's designed for increased infiltration relative to those native soils. So again, reducing the stormwater that enters the storm sewer system, but also providing opportunities for things like horticulture. So you get more trees, more shrubs, more grasses. And you can provide other co-benefits in the form of increased canopy cover, urban heat relief, and you can also attract pollinator species. Our third bucket of asset is our stormwater tree trenches. So these are systems that allow us to capture road or boulevard drainage through the roadway catch basin. And instead of that catch basin outletting that stormwater straight into the storm sewer, it's going to use that stormwater to irrigate the street trees. So again, we have a reduction in stormwater, but then we're also supporting our tree canopy targets. So in Toronto, that's 40% canopy coverage is our target by 2050. So we can also help with urban heat relief through this type of asset as well. And so these assets typically require the use of soil cells. So those are those black boxes that you see underneath the pavement. And these are structures which support the overlying pavement structure, and they contain uncompacted soil media. So they support the tree growth and the hard surface boulevard condition at the same time. So we really aim to provide as many co-benefits as possible through our Green Streets program. So another example is a project on a street called Peel Street, which is downtown Toronto. And here we have this bioretention planter, and it collects roadway stormwater from the curb cut inlet. And you can see that kind of at the right side of the planter in the picture. And it also provides a lot of co-benefits. So it can help with increased biodiversity. It addresses urban heat island effect. You can increase infiltration, get better air quality. And while it's not explicitly called out here, this asset was used for traffic as a traffic calming measure. So in this case, it was used as an element of the road narrowing for this street as well. And you can see that before picture there where the road was a bit wider. So at the city, we have several policy drivers that aim to address themes like emissions reduction, stormwater management, and public realm improvements. So these are the mechanisms through which green streets are either required or supported. And so without these policy drivers in place, it's going to be challenging to continue to implement these assets throughout the city. So as an example, the city's wet weather flow management guidelines sets out targets for development as it relates to water quality, quantity, and balance. And green streets are one of the tools that can be used to meet these targets. Another example is the official plan, and it has policies that speak to green infrastructure implementation on new streets. So currently, some of these policy drivers that are shown here that support green streets are being challenged, and I'll talk about that shortly as well. But before getting into policy challenges, I wanted to touch on how the program is governed. So our assets are multidisciplinary, so multiple city divisions are involved. So we'll use this stormwater tree trench as an example. So the tree is managed by our Environment, Climate, and Forestry Division. The catch basin is managed by Toronto Water, and then the underground soil cell is managed by Transportation. So because the ownership and maintenance are shared, collaboration is essential. So we have a staff level working group. We call it the Green Streets Working Group, and we meet monthly to support the delivery and build capacity across divisions. So that group also reports to a senior steering committee, the Green Streets Steering Committee, which provides strategic oversight. So in some municipalities, there is like a single Green Streets division. Our program is more distributed across divisions. So the governance structure and collaboration are really what make this program work. So now getting into implementation and how these assets get designed and constructed. So there's different mechanisms through which the work is completed, and these mechanisms are influenced by the policy drivers that we just reviewed. And so there's four main mechanisms that we have. So through our capital projects, through private development applications, through transit projects, and also through the city's agencies, boards, and commissions like Waterfront Toronto. And so this implementation at scale is only really successful when we have all of these parties on board. Now, how do we implement green streets? So we use our streets as opportunities. So in Toronto, we have about a quarter of our landmass covered by city right-of-way. So anytime work is completed on a street, let's say a reconstruction or a road resurfacing, this is a great opportunity to implement green streets when our road infrastructure is already being worked on. So the bundling really allows us to control costs and construction impacts on the community as well. And so through our capital program, we don't implement green streets on every single street. It would just be way too expensive, unfortunately. So instead, what we do is we take our road rehabilitation program. So that's about 20 to 30 kilometers of street per year. And we run that list through a a selection process. So that selection process includes a GIS screening exercise. So each street is scored on the parameters shown here, and we review the highest scoring streets. So those are those that are going to benefit from implementation the most. So after that screening is done, we do a desktop analysis to assess the site conditions and whether there's space for that implementation. And then further into design, there'd be a field analysis where you do things like your utility investigation and assess the location of existing utilities. You would also do your geotech investigation to further support your design. So the streets that are selected get programmed and the capital cost is shared between transportation services and Toronto Water. And I'll talk more about cost on a subsequent slide as well. So we're currently looking at a bit of a modified approach to how we prioritize our project locations. So we recently completed an analysis citywide of these inputs. So tree canopy, social equity, impervious surfaces, and urban heat vulnerability. And based on these inputs, we scored each neighborhood and picked the 20 worst scoring neighborhoods that would benefit the most from Green Streets implementation. So we're currently looking at how we can amend our capital programming approach so that we're prioritizing implementation in these neighborhoods and so these are the neighborhoods that are going to benefit the most. But it's a bit of a challenging exercise since we don't necessarily want to lose sight of the opportunities that may exist outside of these neighborhoods. So the ones that are low cost or easy to implement. So we're still fleshing out what this new prioritization framework is going to look like. So I briefly touched on how these projects are funded earlier. So in terms of capital costs, the cost is shared between transportation and Toronto Water, and it's evenly split 50-50 between these two divisions. And now that cost is the delta cost over and above the cost of the bundled work. So the cost over and above the road work that's already happening. So we're currently also working on a modified version of this funding model where the cost would be shared by benefiting agencies. So for example, if we're installing an asset that has trees, perhaps a portion of the capital cost gets funded by forestry, or if the asset's designed to meet a stormwater target, perhaps Toronto Water pays a more significant portion of the ratio of the cost. So that's something that's currently underway. And to support all the implementation that is ongoing, we have a number of resources that were developed a couple of years ago that include standards, specs, and guidelines. And we really want to standardize the assets that get built as much as possible because that's going to help streamline any future operations and maintenance activities for these assets as well. And maintenance is almost as important as the design and construction, especially in the first few years where plants and trees are still establishing. So once they're established, they become much more resilient. And we maintain these assets in a couple of different ways. So through either our city contractors, through our workforce program, by adjacent property owners as required under a city bylaw, and through volunteer groups. So this year we launched an Adopt a GI program, and we now have 5 sites and about 20 volunteers helping care for these planters. And this has been really great, especially in locations without adjacent property owners to help with that maintenance. The program's gone really well, and we're hoping to double it next year. And so not only does it support maintenance, but it also helps build that community space and gives residents a chance to garden and address their horticultural hobbies, even if they don't necessarily have yard space. And so we've had a lot of successes, but we aren't without our challenges either. And those exist at different levels, from programming and policy all the way down to operations and maintenance of our green streets. So I want to highlight 3 of our challenges. So at the programming and policy level, so I mentioned before that we have policy drivers in place that support or require green infrastructure. So one example is the Toronto Green Standard, or the TGS for short. And it has a requirement that was enacted in 2022, which required that new streets include green streets or green infrastructure. Because new streets are basically a very easy opportunity to implement anything. You're working with a blank slate. But recently with Provincial Bill 60, my understanding is that the Toronto Green Standards being completely scrapped. So we're going to lose that mechanism to have green streets implemented via development completely. Another challenge is at the implementation level. So these are there's challenges working in an old big city like Toronto. So most of our streets are so congested with utility infrastructure, and there's often not space for green streets, and the relocation of utility infrastructure is often cost and time prohibitive. So it's not always a likely option. And there's challenges at the maintenance level as well. So it takes time for us to figure out which designs are optimized for operations and maintenance. So for example, we have a standard for trench drains right now, but our operations and maintenance teams have told us that they're super laborious and time consuming. So we're constantly trying to figure out how these designs should really reflect the realities of our operations and maintenance activities. But I do want to end on a positive note and highlight some of our accomplishments. So in terms of programming, we're continuing to increase implementation year over year, and that's supported by more staff training and capacity building. So really building the expertise citywide. So right now, the project managers and engineers that oversee roadworks are all getting trained on GI design, and our inspection teams are getting trained on construction activities as well. So the tiny dots here on the map are our program locations for 2025 to 2027, and there'll likely be more, they're just not mapped out yet. At the implementation level, as I mentioned before, we have a number of standards in spec that were developed, and this includes retrofit design options. So it's a suite of details that show designers what they can do if you already have trees or green infrastructure on a street and you want to improve growing conditions. So this is an important resource to have when you often can't find an opportunity to implement a new green streets asset, perhaps due to utility conflicts, for example. So you can at least improve the growing conditions. So here we have an example where a tree opening was created around an existing tree with permeable pavers installed adjacent to the tree pit. So that allows for that tree to be irrigated and more room for those roots to kind of breathe. And at the maintenance level, we've had a lot of successes with the workforce development program. So it's called Green Force TO. And that program helps us operate and maintain our assets. So back in 2021, it was a pilot project and it was launched. So the city partnered with 2 local social enterprises to both hire and train individuals that were experiencing barriers to employment. So they were hired to maintain our Green Streets assets with the help of with the goal of helping them increase their skill sets and potentially being qualified to be hired by the city eventually. So that brings me to the end of my slide. So I'm going to throw it to my colleague Nilu to get more into the weeds of capital delivery.
Thank you, Anisha. So before we jumping into the details of this example and this project that I've been working on for the past few years, I just wanted to provide an overview of how we are structuring our delivery program for capital projects. So my division, which is Engineering Construction Services, provides design and construction services for other divisions such as transportation services and Toronto Water. And there are multiple sections within our division that would build different types of infrastructure, from treatment plants all the way to bridges, roadways, and linear underground, which is my section. We recognize that the Green Streets implementation within the right-of-way needs to be across the board. Basically, any unit that works within the right-of-way and they are delivering capital projects, they should be able to design and construct green infrastructure. So for that, we understand that this is a new concept. Design and building a GI, it's not difficult, but it's certainly a little bit finicky. So what we worked on with our client divisions is that we started to pick up the locations with different typologies. So this project that you would see on the screen, this is actually our first very scaled up set of projects that we've been working on the design, and we are going to tender this project in the next few months. So you see that on the left, this is basically the existing condition of this road. We normally bundle the green infrastructure implementation with other right-of-way components. So for this particular project, you would see that we will reconstruct the road, and we are going to install sidewalks as well. And along with that, green infrastructure will be implemented. During the design and during the preliminary design, we looked at the opportunities and looking at different and various types of GI that can be implemented within the road right-of-way. So as you can see, this is a rural cross-section street that is normally converted to a fully urbanized cross-section when a sidewalk is being introduced. So what we did, if you see on the photos on the right, you would see that we are going to convert half of the street into an urbanized cross-section. Basically, the street would be a semi-urbanized cross-section, and we are utilizing the existing ditches to install bioswales as well. We looked at other opportunities as well to increase the permeability of the streets. For example, introducing permeable sidewalks or even infiltration trenches underground. But we realized that the benefits of investments is not to that extent that we have to invest on all types of GI. So the low-hanging fruit here was for us to install bioswales where the existing ditches are, especially where at the site that there's no sidewalk being introduced, or bioswales in the back of the sidewalk, and then we basically through a curb inlet and a trench drain, we can discharge the road runoff into the bioswales as well. This is an example of an industrial road in Scarborough. We do have other types of roads. If you go to the next slide, Anisha. These are a cluster of roads, basically. Some of them are residential and some of them are more industrial. So this is an example of one of our residential streets. Same type of scope, kind of same typology, street typology as well. So as you can see, we will reconstruct the road fully, and also introduce sidewalks as well as bioswales on both sides of the street as well. Go to the next slide. So one of the challenges that we have with bioswale planting is the maintenance intensity of these features. We are a big city. We have limited resources to maintain all the plants. So for us, we really rely on some of the homeowners to assist with very high level maintenance of the plants, bioswale plantings, such as occasional weeding or trash collection, making sure that, or just our eyes on the street and then in front of the street, in front of their properties, they can look out for the health of these plantings. So what we did, we reached out to the residents through basically letters to residents that bioswales are proposed in front of their properties, basically. And in our letters, we basically described the type of GI that is being introduced, as well as the benefits and the functionality of the proposed GI. And at the end, we provided the residents with 3 options. You see the 2 of the options, which are the purple and orange planting pallets. And also the 3rd option is sod. Sod is much easier to maintain, and basically if the resident is not going to agree on maintaining these plants, we will sod these bioswales. But through these communications, we basically requested the residents to contact the city and provide their preference and their agreement, basically, if they are going to take on some of those high-level maintenance efforts. As you can see, our planting pallets are native plants. At the very bottom, you would see how these plants are being introduced. We divide the bioswale into 3 zones. The very right, which is basically outside border of a bioswale, it's where more drought tolerant plants are proposed, just because GI is a depressed feature. We would recognize that the plants that are at the very middle of the bioswale, they would be more submerged or more prone to like basically be in the water, but the plants that are being proposed at the perimeter of the GI, they're the ones that have to be a little bit more drought tolerant for our drier seasons. So this is how we basically communicated with the residents and gave them some options, and we received good feedback. I wouldn't say every resident got back to us, but for every street that we send out letters, we received a few responses that the residents are willing to assist the city with some maintenance work. Next, please. Another set of project locations that we selected, if you look at the laneway in the left, this is one of our laneways within downtown area of the city. Some of these laneways are more commercialized than the others. A lot of traffic and a lot of utilities on the ground that we had to tackle and basically come up with some solutions that our project is not costly. We weren't going to relocate any of those utilities because quite frankly, we didn't have any space to relocate them to. And we really wanted to install permeable pavement in these locations as well. So we came up with a pervious concrete design, which is basically a conventional concrete that is more porous. It has a little bit less strength than a conventional concrete, but at the same time, it would be able to hold the loading that is required within these laneways. We did have some utility conflicts within the storage layer of these pervious concrete, but we came up with some protection measures and some communications that we had with the utility companies to have them agree on these protection measures. The photo on the right is a laneway within our more, I wouldn't say it's a suburb, but it's not within our downtown core. This laneway currently is unpaved and it's a gravel laneway without having any storm sewer. So we wanted to basically capture all of that runoff on those streets without connecting the underdrain into the sewer system. So basically we are proposing pervious concrete on these laneways with a vegetated strip in the middle so that any additional water can be captured by these vegetated strips and any drainage into the sewer system is through the overland flow. Next slide. Design challenges. So we are still learning from our design practices, and we have a few other project managers within other units that are providing their feedback during the design. Some of the challenges that we have is with the industry's expertise overall. We have a lot of consultants who are working on GI design, but their expertise is mostly for development applications. Basically, it's very difficult to retrofit a GI within a very confined right-of-way space. It's easier if you have a new street. You have a blank canvas, but with the limited space within the right-of-way, with so many services that need to be provided, it's a little bit challenging and it needs a little bit of creativity to come up with the best GI option as well. So one of the first attempt during the design, and the first one is for us to cite and select a proper GI type for that particular streets, looking at the site constraints, looking at the grading, and coming up with the locations that would capture most of the stormwater and runoff, and what type of GI is best for that location. If we have larger space, we will go with vegetated GIs such as bioretentions or biosoils to convey the stormwater. If not, we'll go through hard surface GI types, pervious concrete, interlocking pavers, and so forth. One of the other challenges is the data collection requirements. For a roadway project, it's very easy to order the field work, basically the surveying, the geotech, and the subsurface utility investigation. It's a little bit different for GI because for the geotech, you have to add infiltration testing, you have to measure the high groundwater tables, and also with the utility conflicts, sometimes it's more labor intensive efforts. You'd have to do some boreholes to really tackle these utilities and really make sure that the utilities are investigated during the design so you don't have any surprises during construction. And that phasing of that data collection, we're still trying to see if the conventional phasing of these data collection works for the GI projects. Maybe we have to move some of that into a more detailed design stage where our GI sites are confirmed or the GI type is a little bit more confirmed. So it's a more iterative process that you select a GI type, you go through some investigation, and then you go back and test the sites and GI types that you've selected in the beginning. As Anisha mentioned, utilities are our biggest conflict, especially in the downtown core. Some of these utilities are unknown. We don't have any record of these utilities, so definitely a borehole, SU 8, SU level A would help us with investigating those utilities, but at the same time, that's a little bit costly as well. Also, mature trees are limiting our GI implementation. By no means we like to remove any mature trees and install a GI, but at the same time, we want to have that infiltration and additional infiltration within our right of way as well. If you go to the next slide, please. The other challenges that we have, it's construction challenges, but some of it is more of a project management challenges as well, because if we don't have a good contract and a proper contract for these GI assets, we wouldn't be able to make sure that the contractor really abides by our specification, our contract documents, and they understand the importance of proper GI installation. One of these challenges was lack of contract templates. All of our project managers they rely on some of these templates, such as special specifications, to make sure that they can communicate the essential items for proper GI installation and the payment method, and for the contractor to understand that before they bid on our tenders. Also, we normally have standardized price list items for items such as roads, catch basins, sidewalks, and so forth, but we don't have any database for GI elements yet, which we're all working on putting together some of those price list items and special specifications as well. We normally have to, well, we always have to put together a construction cost estimate before we tender any capital project, so that the client division can basically secure the appropriate funding before we go through tendering. For Green Street projects, we are a little bit limited just because that we don't have sufficient level of constructions in the past to put together some cost data as well. We do have a list of pre-qualified GI contractors on our tenders as well. However, we do acknowledge that still the contractors have to be more experienced, and as they build more GI, they would be able to build GI as well. So it's a little bit more consuming, and we acknowledge that we have to spend a little bit more time with our contractors as well as inspectors, and we provide trainings every year for our internal and external vendors as well. And again, on utilities, sometimes during construction, you would excavate and you would see on your unknown utilities, and you have to have some measures and some understanding of coping mechanisms basically during construction, what can be done during construction to basically protect the utilities, or making sure that we have some proactive measures to tackle those conflicts as well. Next slide. In terms of basically construction management during construction, we have identified a few items that we've seen as major components that we have to make sure that we communicate that with the contractors as well as our inspectors, and we watch that during construction as well. One of them is erosion and sediment control. Again, because these capital projects are coming with various components, and the contractor has to do some maybe road work first, or they have to do some excavation first, or sidewalk installation. We do have to separate the GI location and isolate that location properly, so that we make sure that there's no sediment or there's no contamination before GI is basically functioning and is in practice, basically. Construction sequencing is one of the other challenges. We have identified the best practices for construction sequencing for various types of capital projects, but that again, it's very important at the pre-construction, before construction commences. It's with the owner, the contract administrator, and the contractor communicate proper construction sequencing before any work starts, so that we all agree on the most appropriate sequencing as well. Material specifications and storage on site. We do have various types of material that needs to be on site, such as storage material, which is basically a very washed stone without any contamination. Growing medium has to meet our specification in terms of having organic matter, sand content, and so forth. We're still having some difficulties with the contractors as well as our inspectors to make sure that the material that is coming on site, it meets really our specifications. Again, our trainings provide that sense to them with providing them some training that how they can recognize that the material that is on site, it's not suitable for GI installation, as well as how they store that material on site. We really don't want to store any of those material more than a few hours, so that the materials are not contaminated with rain or any type of sedimentation and erosion. So that's part of our communication with the contractors as well. In terms of the equipment types, we don't want contamination in our contamination or compaction where the GI is going to be installed, so that we basically the infiltration rate is not inhibited by the equipment basically going back and forth on the native soil, or sometimes even on the installed GI. So we have to look at the type of equipment that is proposed by the contractor, making sure that they're suitable for this type of work, and during the construction, they're not compacting our site either. Vegetation and planting is another item that sometimes it's afterthought for contractors because they do all of those like millions of dollars of work. And then when they come to restoration, because it's only a few $1,000s, they don't really pay attention to the type of plants that they bring on site. And unfortunately, our inspectors are not experts on that level as well. And also sometimes the contract is being wrapped up in a very cold month, maybe in November, when it's not suitable for planting at all. So again, training our contractor, training our inspectors to make sure that the planting is happening in proper planting seasons, as well as making sure that the plants meet the contract documents. One of the other items that we're working with our legal department is that to have some provisions in our contract and our tenders to make sure that the contractor is planting right plants in the right season. And if they not, and these plants basically die during the warranty period, the contractor is obligated to come back and replace those dead plants and vegetation. They are always obligated to come back during the warranty and rectify the deficiencies. But in practice, sometimes that's very, very difficult with the contractor, just because it's only a few $1,000s, and us being a bigger municipality, as our hands are sometimes tight to enforce that clause. So having some holdback, contractual holdbacks, and some maintenance items in our prices has helped us to enforce this matter to some extent. And I think that was my last. Yeah, thank you.
Thank you very much, Anisha and Nilu. That was an excellent summary of all the work you're doing, and with some really nice depth there for people who are actually working in the field. So thanks very much. I just want to point out in the chat, Marie-Claude did post links to the two articles that we have prepared, or I guess the one article that we prepared on Toronto's Green Street program. And we're pointing that out because we actually do have links in there for a few of the documents that they have produced in Toronto. So that might be an easy place to get access to more information about Toronto's program. And there's a number of questions here. I think that one, Anisha, it seemed like there was quite a bit of conversation about challenges in design and maintenance when it comes to snow. And do you want to kind of say anything about that verbally for us?
Yeah, sure. So I think one of the questions, there were a couple of questions about snow storage, and specifically if there were concerns about snow storage being placed within our Green Streets assets. And we do have to admit that does happen. And I think like one of the ways we want to address that is just like additional training of our operations and maintenance crews who are in charge of snow removal, just so that they're aware of what these assets are, how much snow can be placed on these assets like safely with just to not impede their operations the forthcoming year. And also just making sure right-of-ways that are being newly designed, especially those that are part of new developments, have sufficient space within the right-of-way for snow storage. And that may not necessarily be within our Green Streets assets, but elsewhere. So I think that's an important consideration. There was also a couple of questions just about the permeable hard surfaces and concerns about freeze thaw. So that was a great question. And we've also heard similar concerns just in our day-to-day. With permeable hard surfaces, the underlying storage layer or drainage layer is designed for that drawdown of that stormwater. So in theory, there should be less of that freeze thaw concern. But I did mention in the chat as well. So we're monitoring one of our porous asphalt sites. It's a really cool site. It's called Raindrop Plaza, if anyone wants to Google it, where we have a really nice installation there, and that's being monitored. So we want to see for ourselves how these sites are faring. In the last couple of years, we've had a lot of permeable concrete installations, permeable paver installations, especially in laneways in Toronto. So we're going to be looking at those over the next couple of years just to see how they fare.
And there's a question here from Shannon Carey, wondering if Green Street principles could be used for Vision Zero initiatives such as senior zones, school zones, and to calm traffic. I don't know if you.
Yeah, I can jump in on that one. I was just looking at a project yesterday, actually, where we're trying to combine Green Street's scope with Vision Zero scope. So our Vision Zero team identified a road that was, it's undergoing a major road rehabilitation right now. And as part of that work, they're going to be implementing a traffic median for traffic for additional safety. And within that median, they asked us if we wanted to identify any opportunities for any kind of green implementation. So we identified, like, instead of just putting that median as like concrete, let's put some sod and trees. Like it's a simple replacement. So we are working with Vision Zero on that. They also do a lot of intersection modifications. So where they'll kind of normalize intersections, modify the radius at which the corner radii. So whenever these corner radii modifications are made, sometimes that's an opportunity for us to kind of implement green infrastructure within those that newly constructed piece of right of way. So we can implement, let's say, like a curb extension bioretention planter within that Vision Zero bump out. So we are always working with them and looking for opportunities to collaborate with them. Because again, as I mentioned before, we're always trying to bundle works to both save costs, but also minimize impacts to the community and leverage these opportunities that we have.
Fabulous, thank you. Here's another one. Are you able to speak more to the equity prioritization tool? So they kind of mentioned there the different layers that you've mentioned, but what are your data sources and how does the tool drive capital investment in practice?
That's a great question. So a lot of the layers that were utilized were sourced from other data sources available through Toronto Open Data. The tree canopy, for example, was utilized using the tree equity tool that Toronto has as well. So we're using other data sources that Toronto already had. I would need to do a little bit of a deeper dive to see what our data sources are, but happy to follow up with you on that. And then there's also a question about how it drives capital investment in practice. So that's another great question. So right now, what we're trying to do is taking our capital project list. So looking at that road rehabilitation list year over year and seeing which project locations fall into those priority neighborhoods. And then looking at wherever it's feasible, programming those locations first. So that's kind of the direction we're moving towards. And so how can we leverage those priority neighborhoods and program our capital projects in those priority neighborhoods? But I also see that Nilu just turned her camera on, so she may want to add something to that too.
I just wanted to add that not specific to the Green Streets Initiative, but as this larger initiative that it's underway for Toronto under our division, Environment and Climate Division, they are looking at different climate hazards, and they are looking at projections for the future as well, so that they're becoming this oversight table, and they would basically look at the other divisions' actions and their future actions for climate change adaptation and mitigation. And one of the priorities and one of the actions that have been identified is applying this equity lens for capital projects and investments that is required, because if you have hotter days, it's not going to impact every area the same amount. Like, it wouldn't be an equal opportunity. We need to have that equity lens to see how vulnerable our city is to these different hazards that are coming at us. So definitely it's at the larger scale, but it's being worked on right now, but it's not an implementation yet. But we have recognized it as an action that needs to be incorporated in all of our divisions' work plans, not just Green Streets. It needs to happen basically everywhere.
Thank you. And I think if I recall correctly, the report, your Green Street Strategy report, I think it talks a little bit about your equity prioritization process. Is that correct, Anisha? Just for people, if they want to take a look at that to get a clear sense of the layers that you were using and maybe the data sources?
Yeah, I believe it does. But again, if anyone needs any more information on how those layers were developed, I'm happy to share that.
Okay. Any other questions? I feel like we've done a pretty good job. Do you feel like we've missed any in terms of verbally that would be helpful to talk about out loud here? Let's see. I think we've got that. If there's no other questions, I think we will shut them down unless Anisha or Nilu, if you feel like there's anything you would just like to offer just as kind of closing comments or anything you'd like to add. You're good?
Thank you for having us.
Well, thank you so much for coming for joining us today. There was a wonderful presentation and really informative. And thank you for the great work you guys are doing in Toronto. I mean, I think this is really innovative work, and it takes some courage for a city, a municipality, and for staff to sometimes kind of go out there and try things that haven't been done before. And so it's always helpful to hear from people that are doing that work. So thank you for that. And I'll just say to everybody, that we thank you for joining us today, and that Marie-Claude will be sending you a link to a survey. It's a very brief survey. It will just take a minute to complete. If you would complete it, that helps us to prepare better presentations, webinars in the future, so we'd appreciate that. And just another note to say that our next webinar featuring Vancouver's innovative approach to managing coastal erosion will take place on February 25th, and we hope you'll join us then as well. Thank you very much, and thanks again, Nilu and Anisha.